All right, ladies and gentlemen, thanks for joining us. We are on to our next section, which is the uber important exponential functions. All right, we're going to kind of switch this up from what we would normally do in class, just because I don't know. I'm going to kind of just explain it, and yeah, we'll see how it goes, right? So, but anyways, exponential functions are one of the most useful and real life stuff that you'll ever see. We deal with a lot of that stuff with money, right? The rich people in the world, a lot of them have a smart and well understanding of exponential functions, right? The coronavirus, maybe you've seen that graph. That's an exponential function, right? That's causing all this hardship for us. And that's just the math that's speaking to us. So let's just kind of talk about certain parts of this. And I'm just going to kind of jump around. So if you're following along in the notes, maybe it's best to just watch this, right? But for today, we just have one specific question that we're trying to ask. And that's from this example one. And I'm just going to do kind of a bunch of those type problems. Okay? So the one question that I want you to ask is, does this table represent a linear or an exponential function? Okay? And so we're just going to kind of look at the numbers. And in this case, these, A, B, and number 1 and 2 and stuff, we can just kind of look at the math and see what's going on there. All right? So math is just all about patterns. And if you can find those patterns, that's, for us normal people. I consider myself just a normal person, not some brainiac mathematician, if I'm being completely honest and things like that. So you don't have to be uber smart. If you can just recognize a couple patterns in the numbers, you can really get real far in math, all right? So anyways, let's just look at A. Just take a look at those. Do you see any patterns? Well, it doesn't take much thought to see, hey, I'm jumping up by 1 each of those times. I'm adding 1 on each x, okay? And is there any pattern on the bottom part? Well, sure, oops, I erased that one. Sure looks like they're adding 2 each time, right? It doesn't take a brainiac to see, hey, plus 2, plus 2, plus 2, right? If it is adding the same thing every time, this is an example of a linear equation. So we don't have to do any math or any graphing or anything like that. If we did, we would just see the line that would look something like that. Right? Just going to go up in a straight line. Okay? Because a line means linear. Linear means a line. We've graphed those, right? That's y equals mx plus b stuff. Right? So if you're adding the same amount every time, it's linear. If you're not adding the same amount every time, it might be nothing, but it might also be exponential. We got to look at the patterns, all right? So number 1, or letter B, sorry, it looks like you're adding 1 each time. That's probably going to be a theme, right? Always the x's, we're probably going to add the same each time. But what is the pattern from here? Well, you could say, well, Mr. Beek, they're adding 4, and you'd be right on that first step. But are they adding 4 here? No, right? So already, since they're not adding 4 there, you know that it's not going to be a linear function. They're not adding the same thing every time. But is there another pattern? Why, yes, there is. Mr. Beek, I think they're timesing by 2. That would be an example. Are they doing that in here? Timesing by 2 and timesing by 2? Yes, they are. And since they're multiplying by 2, that means that's an exponential function. Okay? So we would answer that then. Because officially the question says not what is the pattern, but it says is it linear or exponential? And I would say exponential. Why? You can just say multiplying by 2. Okay? Simple as that. That's honestly our concept for the for today. And so I think it's going to be pretty straightforward and easy for you. Let me hide my time there. Okay? Let's try number 1 and number 2 of these try it ones. Okay? Do you see a pattern here? Bloop, bloop, bloop. It's adding 1. Do you see a pattern here? From there to there. You could say we're minusing 4 to get from there to there, but we're not minusing 4 there. We're minusing 2 and we're minusing 1. Okay? That's a pattern. It's not the same numbers there, so it's not going to be linear. Instead of minusing, what are they doing? Well, they're dividing by 2, right? Okay? And they're dividing by 2 here, and they're dividing by 2 here, right? What would the next number be if I had to graph that? It would be 4 and it'd be 1/2, right? Because they're dividing by 2. So this one is exponential. Now, other mathematicians would probably say, Mr. Beek, you're doing that wrong, and they'd be right. We don't generally like to write divided by. We want to write everything in the form of multiplying, right? And so if I'm dividing by 2, do you guys all remember that's the same thing as timesing by 1/2? Right? And so that's officially what our answer is going to be, is we're actually timesing by 1/2. Timesing, that was really sloppy there, that says 1/2, and timesing by 1/2, right? So that's what we're going to say instead of divided by 2. Now, if you see the pattern and you're going to write divided by 2, I'm still going to accept it. But later on, when we get to graphing them, the dividing by 2 will definitely not be in your favor. So I would just practice writing the thing as everything is as times. Okay? Next example. You see a pattern? I think they're going up by 4. It's constant, it's the same. Do you see a pattern here? -1, minus another one, minus another one. Since we're adding and subtracting the same amount each time, doesn't have to be adding, really we're adding a negative if you think about it that way, right? So this is going to be a linear function. All right? That's the only concept from today. So I got one more. If you're following along in the notes, you won't see this, but we're just going to plow through a couple examples and we'll call it a day, all right? Is there a pattern from here, these x's? Looks like they're adding 1 each time. Is there a pattern here? It looks like they're dividing by 2, right? And they are doing that every single time. So we're going to say that one's exponential. But instead of dividing by 2, what did I just say that we're going to write it as? We're going to write it as timesing by 1/2. Okay? All right, real quick and pan this. Number 2. Bloop, 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 bloop. Looks like they're adding 1 to me. What's going on from there to there? Looks like they're adding 4, and adding 4. Since they're adding 4 each time, and it's always consistent, back in the day, last trimester, we would say CROC, right? Constant rate of change, and then we would say linear, and we would be right. Okay? Yeah, let me ask you a side question. Let's say that those first 3 were the same, but then this one was a 16, right? So then we'd be jumping up by 5 that time. Since that is not all the same, that would be nothing, right? That would be nonlinear. Okay? But that's a different answer, right? I'll just keep the linear there. All right, and let's quick talk about this one. I see that they're adding 1 each time. And I see that they're minusing 3, minus 3, minus 3. What does that mean? It's a linear equation, a linear function. All right? Do I got any more on this slide? No, I think that's it. All right, how about this one? Determine whether the table represents a linear or an exponential function. Bloop, bloop, bloop. What's the pattern? Plusing 1. Bloop, bloop, bloop. What's the pattern? We're minusing 2. What does that mean? It means linear, because we're adding or subtracting the same thing. On this one, bloop, bloop, bloop. Like my sound effects, you guys? On this one, what's going on there? That one to me, it looks like they're timesing by 2 each step. Since they're timesing by 2 from there, timesing by 2, timesing by 2, that means it's an exponential function. Okay? All right. Oh man, decimals on this next one? That's no fun. Mr. Beak, come on. Why do you have to give us tough ones? Because you guys are smart and you can handle it. Here we go. Bloop, 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 bloop. We're adding 1. Okay? What is going on from this one to that one? You could say, hey, I'm adding 0.75. You'd be right. But I'm definitely not adding 0.75 there, right? So if you ever get like a weird one, and this one's not that weird, it's 1/4. But if you ever get that, why don't you try to find a pattern on a different one? How about from there to there? What are they doing? Well, they're timesing by 4, right? And then just double check, are they timesing by 4 there? Are they timesing by 4 there? Yeah, right? So then, now that I found the pattern that way, then just go back and say, all right, from there to there, is 0.25 times 4 1? And sure enough, it is. So that one tells me that everyone is timesing by 4, and so that's an exponential function. All right? Last one. Aiden, you think you can handle this one? Number 14? I'm going to extend the page so we just see that one. Number 14, Aiden. Bloop, 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 bloop. They're adding 3 each time. What is going on here? Well, I know from here to here, they're either timesing by 1/10, that's the times, or they're minusing 9, right? That's kind of easy, right? You just always look. And then just double check. Hey, what's 1 minus 9? Is it -8? Yes, it is. So from there, they're minusing 9, right? And minus 9 from there, check. And minus 9 from there, check. Since we're minusing 9 each time, Delaney, what do you got for that one? Linear or exponential? It is linear. Okay? A nice straight line of math for us, all right? So I'm going to call it a day for that. A little bit longer than I wanted to, I'm sorry, but I hope you understand the difference between those two. You guys have a wonderful rest of your night. Take care.